Hi everyone, this is me, age 12, playing Space Invaders on my father's Apple IIc. This is probably one of the first video games I played actively, and it just goes to show that it doesn't take that much to have a compelling game if a machine with 128 kilobytes and a few black and green pixels can sort of do it. And nowadays, you're more likely to find a scene like this in our living room. So there's me reading my Kindle, and my husband is playing games on his PlayStation. The nice thing is that he's an avid gamer, and he likes to play highly rated and unusual and creative games. And so that sort of gives me an insight in how interesting and innovative the medium of games can be. And this made me want to myself start, working on my own game. And since I've been working in Haskell for more than the last year, I decided to do this project in Haskell, which would allow me to push my skills in a fun way. So that's what I did. Actually, there was a sound there. Don't know. That's okay, never mind. So the first thing when you start a game is you need a concept. Obviously the search space is infinite. Everything is possible. Your imagination is the limit. And in this context, I really like this Twitter account, which randomly generates games ideas, and which turns out to be really amusing. So obviously, you don't need to define your concepts to a very great detail, because you can still tweak it as you go along. But once you've got your concept, you still have a number of choices, obviously. What is the format you're going to use? You could do a text-based game like the BBC with the Hitchhiker's Guide to the Galaxy, perfectly nice format. Or you could go graphical, but if you go graphical, you can have different flows of your game. You can have turn-based, like Civilization, or you could have a real-time game. And if you have a real-time game, are you going to go 3D or are you going to go 2D? Obviously, your choices are limited by your available time and skills. So making a 3D adventure game as a one-man team would be a tad ambitious. But once you've got 2D, you still have the choice of your perspective. You can have a profile platform game, or you can have a top-down game like this. This is actually the format I went for my game. My game is actually based on the fact that our society is obsessed with extinction-level events. And I wanted to make a more hopeful game with a little alien that goes around that world and resurrects them one at a time. The first technical thing to get going, more or less, is graphics. I chose OpenGL. Why OpenGL? Well, it's very portable. It's open source. It's very powerful. It's actually completely overkill for 2D. But if I want to do a 3D game later, then I'll have the basics. So I went with OpenGL. And the bindings, the Haskell bindings, are actually pretty transparent. So this means that if you find a C++ example online, it's actually relatively easy to transcribe it to Haskell. There's other possibilities like SDL2 or Qt for 2D games. Another library which is really useful is GLFW. It's a C library which will function as a portable layer between your OpenGL and the operating system. It will, for instance, create windows and handle input from various devices. And with a fairly easy utility function you can, which you can find online, you can create a window just like this. initGL itself also simple OpenGL initialization, and the interesting line here, I think, is the last line. because we're doing a 2D game, we want an orthogonal perspective. That is, we're looking down on our XY plane. If you were doing a full 3D game, you would handle perspectives with different angles, which is more complex. So with a very simple, fairly limited amount of code, you have a window going, which doesn't do much yet. Because to do anything, you need the loop. So in any sort of real-time system, you have basically a loop. The pseudocode could go like this: poll input events, react to input and change state, render state, and if you don't exit, loop again. Nothing new there. Obviously, there's no life without state. Even if you have a little character wandering around, you still need to keep track of their XY coordinates to be able to render where they are. A fairly simple sort of first-degree implementation of this loop would go like this. So loop poll events, get the input direction, and then with this function update the state to a new state, which you then render. I have this code online. I'll give you the GitHub link later. And with this simple thing, you have something that will react to keyboard inputs, which is already slightly more interesting than the black window before. There's one bit that doesn't really fit in the pseudocode I was showing before, which is this. Does anyone know why I use this waiting function?
So your CPU would get a rest?
Yeah, exactly. So the answer was, so your CPU would get a rest, and that's true, because if you were going full throttle and looping as fast as you could, your graphical sort of rendering and pipeline would get clogged up because the render frame here must have time to execute. And anyway, we only need about 60 frames per second to have something that is relatively fluid in our game. So it's no problem to add a little bit of delay in this loop. Obviously, when I was looking around through several examples of existing games, I found that a lot of people were using functional reactive programming, which I did as well, because I found it an interesting paradigm, and everyone's doing it, obviously. So the difference between FRP and handling your state the usual way, as other people have already said, is that instead of defining your state as a like, you know, a state structure, a variable, you have signals or streams over time. So the position of your player is a signal over time. And this very simple example we saw before can be expressed like this. Your left key signal gets polled at intervals, and your player position gets adjusted accordingly for every time the key is actually pressed. I used, so this is the original loop. This is the loop, the same loop, but expressed with LREA, which is a functional reactive programming library. If you saw Evan's talk earlier on about functional reactive programming, this is actually one of the higher order functional reactive programming frameworks. It has monadic signals and monadic signal generators. But to explain this code, you capture the external input into a signal, which you can then use in this, because here you define the dependencies between your signal. So you define how your game will basically hang together. And here the only dependency is you move the player. So from an initial state, it will start to move the player depending on the direction key. And the end of this graph is rendering the frame. And since it's a monad, you can use applicative if you're interested. And then the loop itself is this. It will join the network we just defined, which will actually make it go a step along the signal route to the next state of the network, and then you can sort of and render as was expressed here. Very, very friendly author, Elleria. I asked him a few questions along the way. It was always very nice. This is the graph of my game to give you an idea that already a fairly simple game leads to already a more complex, loopy graph of signals. And I'm curious to see where it goes when it gets even more complex. Another thing that I had to actually contact the author of this library for, because I didn't see how to do it, was FRP and levels. So you have these signals which will exist from the beginning of time to the end of time, and that's actually not actually what you want when you have levels, because you want some parts of the state to die when your level finishes. The world you use in your level must stop to exist and get garbage collected, right? And so thanks to him, I got to see that you can add an extra layer to your FRP and have a signal generator for the level. So you generate depending on your need of the level count. And so you have a signal generator in your signal generator. It's a little bit more evolved. So that's sort of the technical side of things mostly. With this you can make your game work, but it's not enough to make it come to life, to be pleasant to play. For that you need, for instance, textures. With textures in OpenGL, you will actually project images onto OpenGL shapes. OpenGL will allow you to draw squares and circles and polygons and whatever, but you want a spaceship or you want a landscape or whatever, and that will be possible thanks to textures. You have vertex coordinates define your shape. Texture coordinates will define the projection of that image onto your shape. So if you want a one-on-one projection of a rectangular image onto a rectangle, then your texture coordinates will correspond. I think my laser pointer is that. So 0, 0 with one corner, 1, 0 with one corner, 0, 1 and 1, 1. So you connect the texture with every corner. If you want your texture to only be in a part of your shape, then you will use a larger number than 1 so that it only projects a small bit. If you want you want only a part of your image to be on your texture, same thing, you sort of use smaller numbers to project this texture. So an interesting thing is that I lost an amazing amount of time because I was playing fast and loose with number conversions. Never use unsafe coerce, and that's not only in games in general, never use unsafe coerce. It cost me literally weeks to sort of figure out that I had to use the right number conversions everywhere. So yeah, that was bad. Since if this is a one-woman show, I didn't have a designer at hand, and I bought a fairly cheap graphical tablet to make my own drawings, which was a lot of fun. And this is my little character. Obviously, it's a little bit amateur hour, so I like this little alien because it has a spacesuit, and you can see its gender. It doesn't have a gender, it doesn't have a face, and for cute factor, it also has toddler proportions, which may or may not have been inspired by my daughter here. So, obviously the sound is also important. I think some games are actually made by the soundtrack. You dream of the soundtrack. So it's a really important element. And I used OpenGL, which is not thread safe, but still works. You can play background music on one thread and fire sound events on the other thread if you take some precautions, and it sort of works. Obviously, now your loop has to express more than one thing. You need to render frame, but you also need to output sounds depending. And so you add, you make a more generalized output function which sort of threads those both outputs, and then you use this, and your sound state should only have the relevant information for your sound. Then we have, obviously, you also need animation. Some parts will be moving as you go. So I first went with a really naive implementation, which is like my little character needs to walk, so I'm going to make the legs move like this. And I literally coded that in the code, like it goes sinus and cosinus. However, if you want something more evolved, you can't really keep on doing this. And for this, you have what is called keyframe animations, where you have a few keyframes which you interpolate between. And if you have a really complex movement going on, you go for skeletal animations, where you define a skeleton for your character, and rotate and translate as it's needed. So that's a even more complex level. I was pointed to Blender for the keyframe animations, because Blender allows you to save object files containing the vertices of those keyframes I was talking about, which makes it easier to then load them and interpolate between them. But Blender is actually not a very user-friendly tool, so I'm still working on that. Plus, I've not seen any examples in Haskell code yet, so I'm sort of making it up as I go along, but it's on the program. Physics. My particular game doesn't require physics. But if you have anything that bounces or falls or jumps or whatever, you need physics. You can roll your own if it's simple enough, or you can use existing libraries. There's a 2D physics library, which is called Chipmunk, and it has Haskell bindings called Hipmunk. And I have a prototype on my GitHub account if you want to have a look. And it works. So what you do with a physics library, you define your space with a gravity. Then you define physical bodies corresponding to your graphical elements. So the physical body has mass, friction, elasticity, joints, etc. And then you step your physical physical engine. Your physics engine, as your loop progresses, you step it through in time as well, and that gets you a result. And what I found actually is it's not that easy to combine this sort of thing with the FRP. So, but I don't need it anyway, so that wasn't a problem. So far, my little game is to the point where I feel most technical hurdles are passed. I can start concentrating on making it playable. So behind it is the first game I made. So this is a little demo. Oh, thank you. So my little character goes and resurrects. So the lessons learned in this is, well, first let's talk about Haskell. So the nice things, types are a really good way to express your domain and the possible state. So that was a lot of fun. Pattern matching, great way to represent your state machines and all the transitions between the various states. And also, I must say, I was impressed with the bindings, with the native libraries, which really mostly worked. So that was handy. Now, there are some unanswered questions because I haven't finished the cycle with this game, which is a first game. Distribution, how can I package this? Porting, how will this port to other platforms? All the libraries I used were supposed to be easy to port, but a friend tried it on Linux and had a sec fault, so it would definitely need more testing. Performance, this is a small game. How will this work when you have 50 levels? How will this work when you have lots of data? Obviously, Haskell is a lazy language by default. In a game, you don't really want that. So use strict or eager data structures and numbers where possible. Also, getting things started was horribly painful. I went through like literally 20 examples by various people trying different libraries, and those libraries either didn't compile or they sec faulted or they didn't work in some way. And so it took me a fairly long time to narrow down to a tool set I could actually work with. And then there's a compilation. So I think the feedback loop when you use such a compiled language is not ideal because you change something, you compile, you start again, you change something. It's not the fastest loop you can wish for. I hear that with C++ games, people embed Lua interpreters so they can directly interact with states with a script, which allows you to test things on the fly. And I wonder if such a thing would be possible with Haskell. So if you're really smart and have time on your hands, that would be a good thing to do. The second thing in my lessons learned is that I think the hard thing is not the technical side. The hard thing in the game is actually making a really nice, playable, attractive game. I already have the feeling that it will take several tries to get to a game anyone would want to play ever. And I was recommended this, which is a deck of cards, which talks about several aspects of the game. So for instance, imagination or fun or whatever, and it has several questions pushing you to think about those aspects. So I found this a helpful thing, but again, I don't think it's an easy thing, whatever tool you're using. Other people have done this, and actually commercially. This is the first commercially published Haskell game called Nicky and the Robots. The graphical framework they used was Qt. And the code is open source, so you can have a look. And I did, but it didn't build on my Mac, unfortunately. There was a lot of this made a lot of noise recently. It's a game studio who managed to run a Haskell, I guess, window, SDL2 window on mobile. So that means they can start developing mobile games in Haskell, which is kind of exciting. And then there's Wayward Tides by the studio Chucklefish. They're hiring Haskell developers interested in developing games. So there's definitely something in the air about this. Finally, this is work in progress, but I figured that since it was such a terrible pain to get started, I could avoid this for other people so that they can get onto the interesting problems of making a game. And so I'm publishing an ebook on Leanpub if you're interested. So, yep, that's it. Thank you for your attention. Thank you. Any questions? Yes, one question.
Did you work with any other game developers in your area? Is there any kind of group like that?
The question was, did you work with any other game developers? Not really. I guess I was in touch with the author of Elleria, as I said, who is a game developer himself, but that's sort of the extent of my contact. I'm a remote worker, so I don't have a huge group of people around me. Yes?
What's your day job, so to speak, or is this your day job?
My day job, I'm a consultant and I do mostly Haskell. Yeah. Yes?
One of the things I found difficult in just doing some hobby game development is the
Pretty early, but I also wondered about that. I have the feeling that that you can only test part of your game successfully. I don't see how you can test, like integration tests again. I have no idea how to do that. So the game, the question was how to test your game. Yes?
You said that the compile loop was the make a change, compile, and then run was long. Have you had much success just using the GHCI graphical to do it, or does that break with a lot of the external dependencies?
So the question was, so the feedback loop was a problem. So did you think of trying the GHCI REPL? I had a look at that. So actually, the things I found online suggested that it was really difficult to do that with OpenGL. So I haven't really got it working myself.
Did you do any research into entity component systems for this, or did?
So the question was, did you do any research in entity component systems for this? No, so I definitely am aware that there is definitely a hole in my knowledge, and there is a very interesting book called Game Programming Patterns, I think, online, which I definitely should check out. But I haven't. No, at this level, I haven't really done it. No.
I just thought it would be interesting. I don't even know how you would go about doing it.
So, any other questions? Yes?
So you said the physics might have been kind of difficult to integrate into the functional language model.
Yeah.
What in particular was difficult?
So I think the problem is that you're already dealing with one massive state machine, which is OpenGL. And the physics is like another massive state machine next to that. And I've tried with a very simple example to make it work. And for some reason, like physical bodies got garbage collected, so I must have been doing something wrong. I find it really difficult to integrate it with this like graph structure and the state evolution. Because like I say, you're working with this big thing, which is like a universe on its own and doesn't connect with the other state signals you're programming. Yes?
Did you look at any, or did you find any frameworks for building games in Haskell or anything like that? Because that's something very common in other
languages.
usually non-functional environments, to save the trouble of having to implement your own graphics stack and your own physics stack and glue all those pieces together.
So the question was, are there any game frameworks in Haskell that would spare you all the trouble of building your own graphical stack, etc.? To tell you the truth, I found one, I guess, 2D game Monad, but it seems fairly limited. It didn't seem to do that much. And also, again, I didn't get it to run. That's a problem. Haskell seems to evolve at a certain speed, and if people are not maintaining their libraries, they die. So, yeah. Any other questions? Yep.
Does your daughter play your game?
The question was, does your daughter play your game? No, she's at mashing keyboard stage, so it's not really working yet. So, okay. Thank you.